Okay, so for part A of my assignment question, they basically just they gave us both prices to be 2 and income to be 100, and we just substitute. It's straightforward. We substitute in the utility equation that they gave us, and we get V is 10. The second part of the question says that what happens when we change the income from 100 to 110. The utility income comes out as 10.5. So there's a utility increase from 10 to 10.5 with a change in income from 100 to 110. In part B, it's basically the same thing, except the income in this case is 8,000. We plug it into the equation, we get V as 89.44. That's the highest, that's the maximum level of utility achievable. Same concept as part A. This is the second part of question B. It's the same thing, except instead of 8,000, the income is 8,010. So in the end, we get 89.5. So then the maximum utility increased from 89.44 to 89.5, which is a minor increase. It means that the change in utility is so minor that we can conclude that it almost doesn't matter, that it doesn't change, because it's a very minor increase between these. It's 0.05, whereas this one it was 0.5. So part C, if the government was going to transfer 10 to a citizen and is hoping that this would achieve the biggest increase in utility possible, who should the 10 go to? Okay, so the 10 should definitely go to the person that decides to allocate their money income so that the last dollar spent on each product purchased yields the same amount of extra marginal utility. This will maximize, this will achieve the biggest increase in utility possible if it goes to the person that does this. Now, for part D and E are connected because they're basically the same thing. I did them in the same graph. For part D, for part E, our part E comes first because the Marshallian demand comes first, then the Higgsine demand. So we say consider that the price of good X increases, right? So with an increase in price of good X, it leads to a consumption and price of good X to shift. So the price of X increases, the shift of X goes from X0 to X1. As you can see in the graph, it goes from here to here while not changing the Y. It goes from here to here, so it's a bit, it goes here like this. It becomes here from, and then we trace that back to the graph here, and we move it from x0 to x1, and the dx is the Marshallian demand curve here. The combinations of p and x in the lower diagram, the one right here, should be connected with a line which we can call the Marshallian demand curve. This is the line that we connected with. That is the Marshallian demand curve. That's for part E, actually. For part D, we're talking about the Higgsine demand curve. How do we find that? Let's suppose that we compensate for the consumer to take back the initial utility. Since he moved to here, we want him to go back to the initial utility, which is this one. How do we do that? We say let's say that that the agent's income increases. So we increase his income to make the budget constraint gradually increase. Therefore, the budget constraint moves outwards until it reaches the original level of utility which we want. So it moved here. We increase the income for it to shift backwards, but it won't shift back to the exact same spot. It will be much steeper. It'll be on a steeper plane. It'll become something like this. It's basically parallel to our previous point that we have. it's supposed to be parallel to it, you know, pretty much. And obviously we trace it back to the second diagram, and it's at the same initial point, right? Because we're going back to the starting point, but because it's steeper, it's also steeper on the second diagram, which we see it goes from hx to this point. We call it the Hicksian demand for x. We connect the old, like the new dots together. It's the curve of hx, the Hicksian curve. Okay. Also, this is only for x, the change in x. Now, the change in y is the exact same thing. Obviously, it's the exact same concept, except obviously it's just minor changes on the graph, like, you know, plotting changes. But it's the exact same concept, you know, pretty much the exact same thing. With shifting in prices, you know, if you increase the price of good Y, obviously this will go down and this will stay the same, so it'll be about something here, you know. Obviously then you have to trace it back to here, and same concept, it's the exact same concept. Okay, so for part F, they want to know, they want us to show that the share of income they spend on each good doesn't depend on the level of income. So when we're referring back to the figure D and E for examples, because in these examples we can say that the price of good X produced no change in the share of income they spent on each good. So what happened here is the income stayed the same, the price changed, and the price of one good changed and the price of the other one stayed the same. Therefore, it did not affect the income of each separate good. We can see this more in an example. If, for example, the level of the income increased without any change in the other factor, like price of a good, of the other good, for example, then the shift in the indifference curve affects only the total utility spent on both, not the share of the income they spent on each good. So shift in income means from U1 to U2. As shown, it doesn't affect the share income spent on each good, since it shifts with the curve. It goes from this point here to this point. They both shift this point here. It moves with the curve. It doesn't affect the shared income for each good separately. Okay, in the last part G, they said, suppose the consumer's preferences are described with the utility function given, so this one. They said that X is all imported goods and Y are all locally produced goods. 75% of what they spent is on imported goods. Therefore, we can deduce that 25% goes to local goods, obviously. They want us to know what is the true price ratio of imported to local goods. So all we have to do is basically just substitute in the equation. Since it's 75% of the income is distributed to Px and Py. So all we have to do is we plug in 75% for Px because X is the imported, and 25% for Py because Py is the local goods. And that gives us our new price ratio of imported to local goods. And yeah, that's basically it. Thank you very much. I am Mark Moucharrafie, 2019 02424.